The discovery began with a whisper of steam and a locked steel door. On October 27, 1945, months after Japan's formal surrender, a group of American engineers stepped through the ruins of a mountainside tunnel complex west of Osaka. The air still carried the metallic tang of recent machinery, and the concrete walls radiated a fading warmth, as if the factory inside had been alive only hours before. They expected to find rubble. They expected silence. They expected abandonment. What they found instead would change everything. When the engineers pried open the final door, a blast of warm air spilled out, followed by a sight none of them were prepared for: an entire underground aluminum processing plant, untouched by bombs, untouched by fire, untouched even by time. Rows of casting furnaces lined the chamber, their steel mouths black and empty. Suspended overhead were conveyor tracks, quiet but perfectly intact. Stacks of aluminum ingots, hundreds of thousands of pounds, lay in neat rows like silver bricks waiting to be moved. The sheer scale defied belief. Someone had built an industrial heart beneath the earth, and kept it beating until the final days of the war. The engineers exchanged stunned glances. During the Pacific conflict, American strategists had been puzzled by one question: how was Japan still producing aircraft in late 1944 and 1945 despite relentless bombing raids? The answer was now staring them in the face. Hidden factories, subterranean foundries, secret smelting plants carved into mountains, shielded from the sky. This one was only the beginning. As the engineers explored deeper, they discovered something even more shocking: documents, blueprints, and machinery setups that revealed a coordinated network of underground aluminum production sites stretching across multiple prefectures. Japan had poured its dwindling resources into protecting a single material more fiercely than anything else. Because aluminum meant aircraft. Aircraft meant resistance. Resistance meant the war could drag on, and American casualties would rise. The engineers stood at the center of the silent facility, realizing they were standing inside the answer to a mystery that had haunted commanders for years. A hidden industry, a hidden strategy, a hidden war beneath the war above. And the discovery would reshape everything America thought it knew about Japan's final defenses. To understand why a hidden aluminum factory startled American engineers in the closing months of 1945, we need to step back into the waning years of Japan's war machine, when desperation forced innovation, and survival demanded secrecy on a national scale. By 1943, Japan faced a crisis no amount of military discipline could disguise. Its cities were burning, its harbors were shrinking, and its aircraft were falling faster than they could be replaced. Aluminum, once the most abundant element in Japan's wartime arsenal, was running dangerously low. American submarines had disrupted supply ships. Bombing campaigns targeted smelters, power stations, and transport hubs. Japanese aircraft designers tried everything: wooden components, mixed alloys, recycled metal from wrecked planes. But nothing replaced the strength and lightness of pure aluminum. And without aluminum, there could be no fighters. No bombes. No interceptes. No resistance. Japan's military leadership understood this with terrifying clarity. So they made a decision that would reshape the final years of the Pacific War. Move aluminum production underground. Literally. Not symbolically. Not partially. But entirely. Engineers, industrial planners, and military officers collaborated in secret to identify caves, mountainsides, and forest-covered ravines that could be carved open, excavated, reinforced, and converted into concealed production centers. Civilian laborers and conscripted workers dug day and night, hauling out tons of rock to create tunnels large enough for full-scale industrial operations. These weren't makeshift hideouts or emergency shelters. They were engineered environments: ventilation shafts, water cooling systems, electrical lines, blast-proof chambers, and ore-crushing halls buried beneath layers of stone. And the deeper the war went, the more this subterranean network expanded. By mid-1944, American analysts noticed something troubling. Japan's aircraft losses didn't match the expected collapse in industrial capacity. Despite the firestorms that consumed major cities, new fighters kept appearing in the skies over Okinawa, Iwo Jima, and the Philippines. The puzzle baffled intelligence divisions. Where was the metal coming from? How were smelters still operating? Why did their production graphs refuse to fall the way every prediction said they should? The answer lay far below ground, hidden from aerial photography, hidden from scouts, hidden from the strategic bombing campaign that crippled every above-ground factory. It was the perfect illusion. To the outside world, Japan looked hollowed out. Inside the mountains, the war machine still breathed. By 1945, as the Allies closed in, these underground facilities became even more important. The factories didn't just supply frontline aircraft. They symbolized the possibility that Japan might continue resisting long after its cities were devastated. That the war might spiral into years of attrition. That an invasion of the home islands would be met with a supply of fighters far larger than expected. The stakes were enormous. Which is why, after Japan's surrender, American commanders sent specialized engineering teams into the countryside with one mission: find whatever the sky never saw. They combed through valleys, riverbeds, forest edges, and mountainsides, looking for fresh tracks, unusual ventilation shafts, camouflaged doors, or power lines that disappeared into rock. Every tunnel was a possibility. Every hillside a potential industrial heart. And on an autumn morning in Osaka Prefecture, their search paid off. The hidden factory they uncovered was not the last, nor the largest, nor the deepest. It was merely the first revelation of a much bigger secret. A revelation that forced American engineers to rethink Japan's wartime capabilities, and to ask, if this was hidden so well, what else lay buried beneath the surface? The deeper the American engineers pushed into the mountain, the more impossible the discovery became. The hidden aluminum facility was not a crude wartime shelter. It was a fully functioning industrial complex. Clean, organized, methodical. Even without workers present, the space felt lived in, as though someone had simply stepped out for a moment and would return to resume production. Pipes still glistened with moisture. The air still held the faint burn of molten ore. Generators remained warm to the touch. The engineers moved carefully, flashlights cutting across machinery arranged with military precision. Some of the equipment was Japanese-made, but an astonishing amount was foreign. German components, Swiss measuring tools, Swedish alloy testing instruments, brought in long before trade routes collapsed. Japan had been planning for this. For years. One engineer ran his hand across a row of aluminum ingots stacked to the ceiling. Each block carried neatly stamped markings, batch numbers, dates, intended destinations. Many were labeled for aircraft plants associated with late-war fighter models. Some belonged to projects the Americans had never even heard of. Another engineer whistled softly as he inspected a massive electrolytic smelter. "This is brand new," he muttered. "Late 44 construction. Maybe early 45. They were pushing full production even when the bombers were over Tokyo. A realization settled across the team like a chilling weight. Japan had been preparing to resist far longer than anyone understood. The factory was only one piece of a puzzle that suddenly felt much larger. They soon found evidence confirming it. Maps pinned to a corkboard, showing supply routes that bypassed destroyed cities. Coded logs detailing shipments to remote airfields. Handwritten notes from supervisors instructing workers to increase output as late as July 1945. One document even outlined an emergency plan to seal the tunnels and continue small-scale production for months, perhaps years. American intelligence had predicted industrial collapse by early 1945. But inside this mountain, collapse had never come. The engineers shared uneasy glances. If this facility had gone undiscovered, how much longer could Japan have fought? How many more fighters could these tunnels have fed into the sky? How many more American lives might have been lost in an invasion? The questions grew heavier as the team reached the far end of the tunnel system. There, behind a final reinforced barrier, they found something astonishing. An untouched rail-loading platform, complete with small electric carts used to move ingots from smelting stations to the exit tunnel. The tracks led to a concealed secondary entrance carved into a hillside, perfectly camouflaged by false rock panels. This factory had been designed not only to survive the war, but to outlast it. The discovery felt like walking into a ghost city, one built for a war that never reached its final act. The engineers documented everything, photographing each machine, each blueprint, each control panel. But every answer they found only led to more questions. How many other facilities existed? How close had American strategists come to misjudging Japan's ability to continue resistance? What could this mean for understanding the enemy's mindset in 1945? They didn't have to wait long for the next clue. Just outside the tunnel entrance, a narrow footpath wound along the mountain ridge. Locals had mentioned nothing about it. Yet the ground bore signs of heavy use: fresh footprints, discarded gloves, broken crates. Following it led to a second tunnel system, partially collapsed but still accessible. Inside awaited an even more disturbing discovery. This second tunnel wasn't for smelting. It was for storage. Stacks upon stacks of aluminum billets were arranged in long corridors, each row stretching dozens of meters. Some billets were wrapped in cloth, others lay exposed, their surfaces still gleaming under the engineers' flashlights. The volume was staggering. This wasn't a backup supply. It was a reserve. One engineer stepped back, stunned. "There must be thousands of tons here," he whispered. The realization hit everyone at once. Japan had buried its industrial heart beneath the earth and prepared to fight a drawn-out, subterranean war if necessary. A war of attrition from below. A war built on hidden metal. And yet, even now, they still hadn't uncovered the full scope of it. As the engineers continued exploring, they discovered two more entrances, sealed with reinforced steel doors. One had been welded shut from the inside. Another had collapsed naturally during an air raid, hiding whatever lay beyond. Each discovery deepened the sense of urgency. This wasn't merely a factory. This wasn't merely a facility. It was part of an entire hidden industrial world. A secret network that forced American engineers to confront a terrifying possibility. What if Japan had been preparing to fight a long guerrilla struggle, not just with soldiers in caves, but with aircraft supplied by mountain factories the Allies could never bomb? The engineers stood in the heart of one such facility, surrounded by silent furnaces and untouched ingots, and they understood the truth. Japan's defeat had come just in time. If the war had continued even a few months longer, these hidden industrial veins might have pumped new life into the collapsing empire, turning the end of the Pacific War into something far darker and far longer. The discovery was no longer just surprising. It was alarming. And it was only the beginning. The climb toward the truth reached its peak when the engineers uncovered the final chamber, a place that revealed everything Japan had been preparing for, and everything America hadn't seen coming. It began with a hollow metallic echo. One engineer kicked aside debris near a collapsed tunnel wall. The ground rang differently there. Lighter, emptier. Curious, he knelt, brushed dirt away, and found something strange. A steel plate embedded beneath the rubble. A hidden floor hatch. The team exchanged looks. The hatch wasn't on any diagram. Not on any blueprint. Not on any production chart they had collected. This part of the factory had never been meant to be found. With pry bars and hammer drills, they cleared the debris, uncovered the full hatch, and finally pulled it open. A gust of stale air rose from below. Cold, hollow, tinged with machine oil. Flashlights cut into the darkness. A metal staircase descended into a chamber twice the size of the smelting hall above. It was an underground cavern, artificially expanded, reinforced with steel ribs, and lined with industrial cages that resembled oversized storage vaults. But what filled those vaults left the engineers speechless. Aluminum. Not ingots. Not billets. Not raw ore. Precision-machined aircraft components, stacked meticulously on wooden platforms. Fuselage frames, wing spars, engine mounts, landing gear struts, all wrapped in cloth and sealed against moisture. The parts gleamed under flashlight beams as if freshly manufactured, because they were. These weren't leftovers. They weren't scrap. They were parts intended for final assembly. Aircraft parts. Enough to build entire wings of fighters. One engineer ran his hand along a perfectly machined spar. "This is aircraft grade," he murmured, awe and alarm battling in his voice. "Late war alloy blend. stronger than the early models. Another engineer lifted a panel covering a crate. Inside were multiple components stamped with a symbol the Americans recognized immediately: the series marking used on Japan's final generation interceptors. One of the engineers staggered back. This isn't just a smelter. This was a ready reserve for rebuilding Japan's entire aircraft fleet. They had found the missing answer to a question Allied intelligence had been unable to solve. How did Japan plan to continue fighting when its cities were gone and its factories destroyed? The answer was now standing in front of them. Hidden factories. Hidden reserves. Hidden assembly lines waiting for the right moment. A strategy of survival by concealment. One officer accompanying the engineers lowered his flashlight slowly, face tense. If they had gotten these parts out, if planes based on these components ever launched. He didn't finish the sentence. He didn't need to. Everyone in the chamber imagined it. New Japanese fighters, built secretly, rolling out of mountain tunnels after Allied air patrols believed the skies were clear. A sudden surge of resistance. More kamikaze attacks. More pilots. More lives lost. More months of warfare. And then the engineers found the documents. In a sealed iron cabinet, secured by a rusting padlock, they discovered folders filled with detailed reports, site-to-site delivery schedules, production quotas, and contingency plans for maintaining aircraft output even if major population centers fell. One file was marked, Phase 3 Mobilization. Inside, the engineers found instructions to distribute the parts stored in the lower chamber to hidden airfields across Honshu. Airfields dug into hillsides, concealed with sliding forest camouflages, built for planes that had never flown because the war ended before they could be assembled. A chilling realization spread across the group. They weren't inside a lone facility. They were standing inside a cornerstone of an entire underground aircraft program. A program meant to carry the war far into 1946, perhaps 1947. The silence in the chamber felt heavier than the steel walls. One engineer whispered what everyone else was thinking. We were never looking in the right place. Above ground, Allied bombers had wiped out Japan's visible factories. But below ground, protected from firestorms and napalm, Japan's war machine had prepared for a hidden second life. A life that never came, because the war ended before the tunnels reached full capacity. The engineers continued documenting every detail, every component, every chamber. But even as they worked, a sobering truth settled into their minds. If Japan had been able to finish this network, if these parts had fed an underground assembly system, they would have faced a far more formidable enemy than the one they had fought in the open. A war of shadows. A war supplied by mountains. A war built on metal buried beneath the earth. The discovery wasn't just shocking. It was a revelation that rewrote the final chapter of the Pacific War. When the engineers finally emerged from the tunnels, the sun was already lowering behind the mountains. The air outside felt different. Lighter, colder, almost unreal after the heavy claustrophobia of the subterranean chambers. Yet their thoughts remained tethered to the silence beneath the earth, to the metal that glimmered like buried skeletons of a war that very nearly took a darker turn. They stood at the tunnel mouth, staring at the landscape. Forests whispering in the breeze, villages tucked quietly between ridges, roads little more than thin brown veins running through green hills. To a casual observer, this place would have looked peaceful, harmless, ordinary. But now they understood the truth. The mountains themselves had been weapons. As their reports moved through military channels, American commanders reacted with disbelief that slowly transformed into sober understanding. The hidden factories revealed how profoundly Japan had adapted to strategic bombing. They showed that the empire's war planners had anticipated collapse long before it came, and had prepared ways to prolong the conflict from beneath the soil. For the engineers, the shock deepened in the weeks that followed. Their discovery near Osaka was not an anomaly. Across Honshu and Kyushu, inspection teams found more tunnel networks. Some partially built, some fully operational, others abandoned in panic as surrender loomed. In one, they found engines coated in protective oil. In another, crates of specialized tools. In yet another, unfinished aircraft frames hanging from steel supports like ghosts waiting to be awakened. Altogether, the hidden facilities rewrote the Allied understanding of Japan's final months. Historians would later note that had the war extended even a few months longer, had certain supply lines not collapsed, had fuel not run dry, had American offensives stalled even briefly, the underground industry might have played a decisive role in prolonging resistance. Japan could never have won, but it might have forced a far bloodier, far longer conflict. This realization added a chilling weight to the engineers' findings. They had not simply uncovered metal. They had uncovered a path the world narrowly avoided. As the post-war months unfolded, American technical teams documented every component and blueprint. Some were shipped to the United States for study. Others remained stored in archives. But the tunnels themselves, those enormous caverns carved by thousands of laborers, were eventually sealed, reclaimed by nature, or converted into harmless civilian use. The engineers who discovered the Osaka facility returned home with memories that would shape their understanding of war forever. They had seen destruction in bombed cities, yes, but this was different. This was the hidden face of war. Quiet, methodical, buried out of sight, waiting in silence to rejoin the fight if given the chance. Years later, when historians look back on 1945, they often spoke of the firebombings, the island battles, the surrender ceremony aboard the USS Missouri. But beneath all of that lay this quieter truth. The war might have ended differently if those tunnels had become operational. The engineers never forgot that. And in the decades that followed, as Japan rebuilt into a peaceful industrial power, the mountains that once hid the empire's last hope for resistance stood quietly, unchanged, unmoving, holding secrets of a war they nearly prolonged. The silence in those tunnels today is complete. But it echoes with the weight of what almost happened.